Thank you, Professor. Thanks to the organizer for this opportunity. I have no conflicts to disclose. So, as we have heard already this morning, NOTCH1 is one of the most recurrently mutated genes in CLL, and we know also that mutated cells benefits from increased signaling capacity and increased pathway activity that ultimately impacts in promoting CLL cell survival and mostly migration, likely making these cells more prone to reach and recirculate from privileged niches, lymphoid niches. So based on this, we wanted to step forward and we asked whether, first, are there crosstalks between other microenvironment-driven pathways? And second, does carrying NOTCH1 mutations give further advantages to CLL cells in the context of this microenvironment network? Among others, we first looked at the BCR signaling, BCR receptor signaling, as it represents a major driving force in CLL and whose signaling intensity has a direct impact on disease outcome, as already outlined by Professor Graham earlier. And to this aim, we put together and examine and compare BCR receptor and NOTCH1 signaling in a cohort of primary CLL samples that were carefully selected to fulfill specific criteria. So first of all, we selected them to have unmutated IGHV genes just to focus the attention on the strongest BCR receptor signalers. Then cells were selected to carry either normal fish profile or deletion 13 as cell abnormality to exclude those chromosomal aberrations that are per se associated with an increased signaling capacity and could raise misleading conclusions. And this is particularly true in the case of trisomy 12 samples, which are enriched in NOTCH1 mutated cases. And lastly, indeed, the cohort was selected and split in order to have on one side fully clonally mutated NOTCH1 mutated cases, and on the other side, completely wild-type cells. And we were able to put together more than 20 samples in each subset with all the main features of CLL that were equally distributed and that were consistently exploited in the experimental settings that I'm going to show you. So we thought that the BCR and NOTCH could be linked together in a loop of reciprocal modulation. And so we first decided to open this loop by exogenously activating either partner. So for example, to activate NOTCH, we treated cells with EDTA just to obtain a rapid and massive NICD cleavage. And within this condition, we observed a different response according to the presence of mutations, meaning that in NOTCH1 mutated cells, full pathway activity was already there after a short and transient EDTA stimulation, whereas to obtain similar levels of activity in the wild-type counterpart, we had to prolong EDTA exposure up to 6 hours. Within these conditions, we observed that upon NOTCH1 activation, there was an upregulation of BCR receptor expression, of IgM expression at the cell surface that was consistently observed in the cohort examined, together with a transcriptional upregulation of LIN, BTK, and BLINK, which encode for structural players in the BCR receptor signaling cascade, and also in keeping with previous literature showing them belonging to a BCR-related NOTCH1-dependent signature. And indeed, if we compare cells in a more baseline condition, so shortly after blood recovery, we observed that NOTCH1-mutated samples were constitutively characterized by increased levels of surface IgM, and that if we engage the receptor with an anti-IgM antibody, they respond with a stronger signaling capacity, as evaluated both by intracellular calcium mobilization, phosphorylation cascade looking at BTK, PLC-gamma2, and ERK that were consistently more phosphorylated in a mutated subset, ultimately leading to an upregulation of a BCR signature where we looked at MYC and CCL3 as the more representative genes. And you can see that indeed, the gene expression is significantly induced in both subsets, but significantly more in the mutated cells, and that importantly, the stimulation of the BCR receptor in the presence of DAPT is able to significantly limit the induction of target genes, as it was somehow, let's say, leveling the differences between mutated and wild-type cells. And most importantly, the addition of DAPT to ibrutinib led to a almost complete shutdown of the signaling, which was not always achieved when using ibrutinib alone in the mutated subset. And in collaboration with Professor Forconi and Professor Packham in Southampton, we also looked at global mRNA translation as a validated process that is induced upon B-cell receptor activation. And again, here you can see that the process is significantly induced in both subsets. But again, mutated samples respond far better. And again, ibrutinib used as single agent is not always sufficient to completely inhibit the process unless GIPT is added to the experimental setting. And when we looked specifically to some RNA, we found that notch on mRNA itself is a specific target of BCR-induced translation, as it was enriched in the latest fraction of a polysome profile. So mRNA was more bound to polysome fractions, marking active translation. And this was quite specific for Notch because, for example, its ligands didn't undergo such a modulation. And this enrichment in translation was accompanied by an upregulation of Notch expression at the cell surface, which was no longer seen if we simulate the B-cell receptor in the presence of either ibrutinib or cyclooximide, which is a potent translation inhibitor. So what do we know so far? What do we know so far? We knew that by activating the BCR or Notch, we obtain an upregulation, an each other upregulation, and that Notch1 mutated samples benefit from show increased signaling capacity of the BCR. But this upregulation was not surprising, as we were surprised by finding that stimulation of the B-cell receptor led to the upregulation selectively in Notch1 mutated samples of delta X1 and HES1, which are pure Notch1 target genes, suggesting Notch1 pathway activation. And this was kind of not expected because we always knew, and everybody knows, that Notch1 activation requires the ligands to get activated independently of the presence of mutations. And so we came across the literature and we stepped into this nice paper that was recently published where they describe that Notch1 can undergo ligand-independent activation upon T-cell receptor activation due to calcium fluxes or PKC-dependent activation of NICD cleaving machinery. And so we tried to mimic this condition in B cells by treating them with PMA and ionomycin, which are potent activator of both processes. And indeed, you can see that, particularly in the case when PMA and ionomycin are given together, you can see that there is a massive NICD cleavage and upregulation of target genes, both at the mRNA level and at the protein level. So we tried to sketch out the loop that we were thinking to link the BCR and Notch together, and we think that it may go as follows. So let's start from the B-cell receptor side. B-cell receptor activation indeed induces its own signaling cascade, ultimately leading to the upregulation of a gene signature, including MYC and CCL3, and upregulation of mRNA translation. And these are among the mechanisms through which the B-cell receptor controls leukemic cell behavior and responses. But through mRNA translation, BCR activation also directly modulates the Notch1 expression at the cell surface, not only, but also it promotes its ligand-independent activation by mobilizing calcium stores and activated NICD cleaving enzymes via the PKC. Active Notch in turn directly impacts on B-cell receptor signaling capacity, both at the transcriptional levels, either by encoding structural players of its cascade or by contributing to enhancing a BCR-dependent signature. And also at the translation level, likely upregulating surface IgM levels and starting a feed-forward loop that is always there and is always maintained. So the question now is there space, is the dual targeting of BCR and Notch of any therapeutic relevance? Well, the answer is maybe. The answer is it will be also discussed later on this afternoon, and maybe it should be carefully thought for special CLL subset or maybe in Richter syndrome, as again will be discussed later. But again, I mean, it could be a possibility. And before closing, I just would like to thank Professor De Aglio and my coworkers, especially Dr. Bracciamà, who helped me a lot performing experiments, Professor Forconi and Professor Packham for their precious advices and collaboration, and all the clinicians that made this possible by providing samples, Dr. Kosha, Dr. D'Arena, Professor Gaidano, and the Cornell unit, Professor Furman and Dr. Allen. And thank you all for your attention.